All right, so this is for 05. This is going to be based off of the simulation that you do. So you should have finished the top portion of this to the best of your ability. It is on Schoology, and you're using that PhET simulation here. So if you open that up, well, that's not quite Safari now, is it? If you open that up, you'll end up going through this nice little demo here, this little simulation. And what I want, and for some reason my stylus doesn't seem to be working with, there we go. Anyway, so this is going to be a very basic representation of an atom. It's going to be able to show us kind of where these little portions, these little particles go. That's what we're going to start talking about here in a little while. So when I put these over here close to the atom, you'll see I have to put them somewhere. And notice where those go to. So this is kind of just a recap of that. Now let's see. Oh, look, the electrons went to the outside in those what we call orbits. You can see there. So just a little bit of kind of going through and double checking what everything contributes, right? You'll see that some of these contribute to the mass number, some contribute to the element, some contribute to the charge, and the charge can be positive or negative, as we can see. So you're just using that information to kind of help you out and figure out, hey, what did those things contribute to the atom itself? So in this case, going back here, you should have done that, and now we're really going to just talk about down here a little bit more more formally about all those parts. So in this case, at the top part, the major part is the center of the atom we call the nucleus. All right, the nucleus is the center and has all the mass of the atom, right? It's very dense in there, coming back to the word density, because those particles that are in there actually weigh a little bit of a certain amount. Over here, inside the nucleus itself, you'll see that there's two types of particles. You'll see one's a plus sign, and the others are, there's nothing. The ones that are nothing are the neutrons. Oh, changed it up on you with the colored pen. Right, the neutrons are neutral. The ones that are positive in there are the protons. Again, you figured this out using the simulation above. Outside, D, right, these things, and it can be this one as well. Those are what we call the orbits. You could say orbits, orbitals. I like to say energy levels, and you'll kind of see what I mean when we get closer to that portion in our units coming up here shortly. And then, of course, these little particles out here, these are all actually negatively charged. And these are our electrons. Now notice our electrons do not exist inside the nucleus. They actually kind of circle and orbit around the nucleus. And things that you are probably already aware of because you've been around the world for a little while now. These are negative and these are positive, and I know that they like to attract each other, right? Positives and negatives attract. So the positives inside the nucleus actually hold the electrons close to them. Now, of course, we know that also if opposites attract, well, these negatives do repel each other, so they don't really like being too close to each other. All right, and again, we'll talk about those types of interactions here shortly. Oh, special guest Benny in the back barking. Sorry about that. Gotta love snow days, huh? So when we're going through this, and we're going to go through this all very quickly, the two things that are in the nucleus are the protons and the neutrons. And then I'm going to say outside the nucleus, or in orbitals are the electrons. All right, and we can again see that there. What is the charge? What does it contribute? Well, the charge for protons is +1 for each one that we have. For neutrons, there is no charge. We call that neutral. And then the electrons each have a negative charge. So that's going to come into play here a lot when we get into some bonding stuff. And then last but not least, mass. Basically what you can say is, if you want to give it a number value, you can say that for every proton we have, we gain mass, 1 unit of mass. Same with the neutrons, because again, they're both in the nucleus, which means that since they're both in the nucleus and that's the center, that's where all the mass comes from. So what we can say is the mass of these atoms is based on the protons and the neutrons, and we'll get there in a sec here. And then, of course, you say 0. There is no mass from the electrons. We say what that is negligible, which means it's insignificant enough for us to account for the mass of the electrons within the atom. So that's basically the gist of the 3 subatomic particles, lower than the atom, right, that make it up. So what do we have here? And we are going to use our periodic tables that you get to be able to help you out with this. In terms of our periodic tables, all you have to do is reference them and the ability to identify different things. And we'll talk about kind of how to read that in our notes here in a little bit. But in terms of the symbol itself, we can actually go right into kind of what all of these things mean. Magnesium. All I have to do is find where the word magnesium appears on the periodic table, and I notice that that is Mg, right? And now each element, remember, each element is represented by at least a capital letter, right? Some elements are represented by a capital letter and a lowercase letter, kind of like these first two. But regardless, there's only one capital letter for every element. So anytime I see another capital letter, I know that I'm dealing with another element. So we look through, and the atomic number, and we talked about this in the notes, where the atomic number is actually the big bold number at the top, right, in the top of that box. When we're going through, the cool part about this is that the atomic number and the protons are the same. So the protons and the atomic number are exactly the same always. So if I know one, I know the other. And that's the identity of the element. And because I know that we're talking about atoms, I give you this little blurb right here. Atoms are electrically neutral. That means that the positives have to be equal to the negatives, right? The protons have to be equal to the electrons. So if I have 12 protons here and I'm talking about an atom, that means I have 12 electrons, right? The positives are the protons, the negatives are the electrons, and this is probably going to be the hardest part of this, but it's not terribly difficult. The neutrons. We said that the mass is made up of what's in the nucleus, which is the protons and the neutrons. So those two add up together. Now, I give you the mass here, which is 24. And I know that that's based off of the protons plus the neutrons. Let me move that over a little bit so it's a little bit nicer. And then, there we go. So because I know that, and I know how many protons I have, if I have 2 out of the 3 of those, then I know how to figure out the neutrons, right? The neutrons would just be the mass number minus the protons, or the atomic number, because they're all the same. So in this case, I take 24 minus 12, which is the protons, and that gives me 12. So that's 12 neutrons there. All right, let's hop to cesium. Now, you are going to have a periodic table of your own. So I'm going to kind of show you that periodic table here. And hopefully, yeah, good thing. It's not wonky. Sweet. So again, how we read these, we talked about this in the notes. The atomic number is at the top. You have this average mass that we're not going to talk about too much right now at the very bottom. You have your name and your symbol. So let's look at where CS is. And we see CS is right here, which is cesium. Now, cesium has an atomic number of 55. So I'm going to write that in. Atomic number 55. The element name was cesium. And now I have to fill in the rest. Well, the cool part about it is, remember, the atomic number is always equal to the number of protons. So that's 55 as well. And then I know, because atoms are neutral, the number of positives, which are protons, is equal to the number of electrons, which is also 55, right? These should be equal to each other. So 3 out of all of these boxes should always be the same for atoms. And the last thing is to figure out what the mass number is. Now, the mass number, remember, is protons plus neutrons, because that's what's inside our nucleus, where all of the mass is. So I have the neutrons, and now I take that and I just add it to the protons, right? Protons is 55, neutrons was 78. 55 plus 78 off the top of my head, just kidding, I have a calculator right here, just to double check, is 133. All right, so again, this is pretty much kind of like a puzzle. And what you're doing is you're taking what you know and you are figuring out how to fill in the rest. So let's do one more together, and then we can do a couple more when we're all together. But the atomic number here, 18, remember, is equal to the number of protons and is equal to the number of electrons, because atoms are electrically neutral. The positives have to balance out the negatives and vice versa. And here I give you the neutrons again. So we can actually figure out the mass number by saying, if I have 18 protons and I have 22 neutrons, that should give me 40 as a mass number, right? Those added up. And now, wait, I don't have a symbol or an element name, so how can I figure that out? And remember, the atomic number is the identity. So since it's the identity of the atom, we can actually use the atomic number to figure out what is this particular substance. All right, and now we look, number 18. Let's figure out what number 18 is. Number 18, and I'm looking, remember, the atomic number is at the top. So I'm looking, I go, and it goes in order, so nice. And 18 happens to be right here, right? That happens to be argon, which is a noble gas. So we have argon, and we have officially worked through that one as well. So try out these yourself. There's going to be a whole worksheet to do after that. But this is going to be something that we can revisit and rehash when you get there. All right? See you later.